Plastics are everywhere. Every week, without even realizing it, we are consuming the equivalent of an entire credit card in plastic. We are unknowingly ingesting and inhaling millions of plastic particles every year. And these tiny particles aren't just passing through, they're accumulating in our organs and our tissues. In early 2024, human brain samples were found to have, on average, 0.5% plastic by weight. In the reproductive system, higher levels of plastic like PVC have been linked to lower sperm counts. And it doesn't stop there. These microplastics are often made from or contain harmful chemicals like BPA, BPS, phthalates. These are widely used to harden plastics, make them more durable. And these chemicals are known to disrupt hormones. They alter metabolism. They've been linked to a range of health issues from reproductive problems to neurodevelopmental diseases. But how are these microplastics entering our bodies? And why are they so pervasive? The primary routes of exposure are oral ingestion and inhalation. We're consuming them through bottled water, through tap water, packaged foods, and even fresh produce that's contaminated by polluted soil and water. We're inhaling these microplastic particles suspended in the air, especially in urban environments where synthetic clothing fibers and degraded plastic waste become airborne. And they don't just pass through us, they are accumulating. They've been detected in the lungs, liver, heart, brain, reproductive organs, and even in the placenta. This widespread presence raises critical questions about what these microplastic particles might do to our health. Could they be disrupting our cells, altering our brain function, contributing to chronic disease? In today's episode, we're going to dive into the reality of microplastic exposure. We're going to discuss how these particles get into our bodies and what it might mean for our long-term health. We're going to explore how plastic could be influencing everything from our brain health to our reproductive health. And importantly, we're going to talk about actionable steps to reduce our exposure to them and help our bodies get rid of them whenever possible. Microplastics are everywhere and they're small. They're really small. We're talking about particles ranging from 5 millimeters in size, so that's like the size of a grain of rice, all the way down to 100 nanometers, which is about 1,000 times smaller than a grain of sand. When they're that small, they're called nanoplastics. And these particles are the result of larger plastic items breaking down over time through a process called oxidation. So this is a slow but relentless breakdown process. Actually, more than 70% of microplastics come from this breakdown from larger plastics, while the rest are intentionally added to everyday products like microbeads in cosmetics, fibers in our synthetic clothing, and also industrial plastics used in manufacturing. But here's the real issue. We're exposed to these microplastics almost constantly, and it's happening through two primary routes: oral ingestion and inhalation. So think about that. When we're drinking water, eating food, or simply just breathing, we're taking in microplastic particles. And the numbers are actually staggering. The average person inhales or ingests up to 120,000 microplastic particles per year from sources like tap water, bottled water, and packaged foods. And it's not just the obvious items. Microplastics have been detected in seafood, in fruits and vegetables because they're contaminated in our water, in our soil, and also in the air around us, which lands on the fruits and vegetables. Also, we have utensils, cups, baby bottles, like plastic items that we're using every day, and these things are shedding microplastics directly into the food and drinks that we consume. Tap water alone can account for the ingestion of anywhere between 220,000 to 1.2 million microplastic particles per year, depending on the source. Studies show that people who drink bottled water exclusively could consume up to 90,000 more additional plastic particles per year compared to those who only drink tap water. So the contamination in bottled water is often due to that breakdown of plastic through the oxidation process itself. Why does this matter? Because while tap water contamination often comes from environmental sources, bottled water brings an additional layer of plastic leaching from the packaging itself into what we're drinking. So what can we do about it? Well, one solution we'll dig into later is using a reverse osmosis water filter, which can filter out not just microplastics, but also nanoplastics and other contaminants. It's actually one of the most effective tools we have for cutting down our exposure to microplastics and nanoplastics in our water. But before we go deeper, I want to highlight another really unsettling aspect of microplastics: their role as carriers for harmful chemical additives. So plastics often are infused with chemicals such as BPA, BPS, phthalates, and the PFAS. These are the forever chemicals, and they're infused with them to enhance the durability and flexibility of the plastics. And so these chemicals come with significant health risks, which we're going to cover in more detail in a moment. But take BPA, for example, or even its counterpart, BPS. These compounds can mimic estrogen in the body, leading to hormonal imbalances that affect everything from reproductive health to brain function. Actually, a study published in the Journal of Hypertension found that drinking from aluminum cans lined with BPA-containing resin can increase blood pressure within just a few hours, which is really a clear indicator of immediate impacts on our cardiovascular system from these endocrine-disrupting chemicals like BPA. Phthalates are another group of chemicals that are commonly used to make plastics more flexible. They've been linked to endocrine disruption, reproductive issues, and developmental problems in children. Research actually has reported that higher levels of phthalates correlate with decreased testosterone levels in males, affecting everything from muscle mass to mood. Then there's the PFAS. So these are the per and polyfluoroalkyl substances. They're often called forever chemicals. I'm going to refer to them as PFAS throughout the podcast. But the reason they're referred to as forever chemicals is because they resist breaking down in the environment and they accumulate in our bodies over time. So PFAS are used to make products resistant to water, oil, stains. They appear in things like nonstick cookware, water repellent clothing, and even food packaging. Exposure to PFAS has been associated with immune system suppression, thyroid dysfunction, and increased risk of certain cancers. But what's even more alarming is how easily these chemicals can leach out of plastics, especially when they're heated or when they're in contact with acidic or fatty foods. So think about that hot takeout container, you pour soup in it, or plastic water bottles that are left in a hot car on a sunny day. Many paper cups are lined with plastic, and when we pour hot coffee or hot water to make tea into the cup, we're not just getting our caffeine boost, we are ingesting microplastics that are breaking down from the heat, which accelerates the oxidation process. And we're also getting a slew of chemicals like BPA. So one study found that heating polycarbonate bottles to just 100 degrees Celsius can increase the release of BPA up to 55 times. And it doesn't stop there. Most canned foods and beverages are stored in cans lined with plastic that can leach these chemicals like BPA and phthalates into our food, especially when that food is acidic or fatty. So a recent study found that microwaving food in plastic containers can release over 4 million microplastic particles into a meal in just 3 minutes, along, of course, with the chemicals they carry. Have you ever microwaved popcorn? I have. That bag is often lined with the forever chemicals, PFAS, to prevent oil from soaking through the bag. When heated, these chemicals migrate into the popcorn, adding, of course, a chemical burden to our popcorn without us even realizing it. Remember, PFAS are called forever chemicals because they are very resistant to degradation. In fact, the half-life in our bodies is from 2 to 5 years. It's the cumulative effect of these exposures that's a growing concern. These chemicals don't just pass through our bodies, they accumulate over time, potentially leading to long-term health consequences. So understanding the sources of exposure is really important for us to be able to take proactive steps to minimize them whenever it's possible, whether that means choosing products that are packaged in glass or avoiding microwaving plastic or using popcorn bags, or even just bringing our own reusable to-go coffee mug to the coffee shop. So we'll get into this more later when we cover mitigation strategies. But I do want to mention, unfortunately, microplastics are not confined to contaminated food and water. They're also present in the atmosphere, in the air we breathe. This allows them to enter our respiratory system, where they can then lodge themselves deep within our lungs. In fact, this raises significant concerns about potential chronic lung inflammation and other health issues associated with long-term exposure. But also, breathing in microplastics is one way to get them into our circulation. And once they're in our circulation, they can make their way to organs and tissues. A major source of airborne microplastics is actually synthetic textiles used in clothing. This is polyester, nylon, acrylic fibers. Every time these fabrics are washed, they shed tiny microfibers, microplastic particles that can enter waterways and eventually end up in our tap water and our oceans. But it's not just about water contamination. These microfibers become airborne as well, meaning we inhale them during our regular wear, especially when handling laundry. Indoor dryers can exacerbate this issue if not properly ventilated to the outside, although ventilating merely does just shift the microplastic exposure to the environment and contributes to broader air pollution. Another significant contributor to airborne microplastics is tire wear and the degradation of synthetic soles on our shoes. So each time we drive or we walk or we run, tiny particles of rubber and plastic are worn away and they're released into the air. And these particles become part of the ambient dust we inhale every day. In urban areas with high traffic density, this can represent one of the most substantial sources of airborne microplastic exposure. And it's important, I really want to note this, that air pollution, including particulate matter like microplastics, has been increasingly recognized as an environmental risk factor for neurodegenerative diseases like Alzheimer's disease. In fact, I've discussed this in great detail in a previous episode, episode 79, with neuroscientist Dr. Axel Montaigne. Make sure you check that out if you want to dive more into the role of air pollution in Alzheimer's disease. Understanding these sources of microplastic exposure, again, is really important because it helps us develop strategies to mitigate our exposure. And we are going to discuss those mitigation strategies later in this episode. But first, it's essential to address a pressing issue that often goes unnoticed. Microplastics don't just pass through our bodies, they bioaccumulate. So every breath we take, every bite we eat, every sip we drink introduces these tiny microplastic particles into our system, and they don't just vanish. They're settling into our lungs, into our livers, our kidney, our bloodstream, and even into our brains. And along with them, they're carrying these harmful chemicals like BPA and phthalates, right? These might be altering our health in ways we're only beginning to understand. So let's start with the lungs. There was a study published in 2022 that examined lung tissues from surgical patients and found microplastics in every single sample. And what's striking is that these patients had no significant environmental exposures beyond just daily life. Researchers identified various types of microplastics, including polyethylene, polypropylene, and PET, the same plastics that are found in everyday items like bags, bottles, clothing fibers. In the lungs, microplastics can cause inflammation and oxidative stress, and they can contribute to respiratory issues like asthma and COPD. One study found that microplastics could reach the lower regions of the lungs, which was previously thought to be unlikely due to the body's natural filtration mechanisms. This discovery suggests that inhalation is a more significant route of microplastic exposure than we previously understood. But the lungs are just the beginning. The liver, our body's primary detoxifying organ, is another critical site where microplastics accumulate. Research has shown that liver cells exposed to microplastics exhibit significant disruptions in functions. So specifically, they have mitochondrial damage and increased oxidative stress, both key drivers of conditions like non-alcoholic fatty liver disease. A study compared liver tissue samples from individuals with liver cirrhosis compared to those who had healthy livers. The cirrhotic livers contain significantly higher levels of microplastics compared to normal healthy livers, suggesting these microplastic particles could play a role in liver disease progression. This is alarming because it implies that microplastics aren't just innocent bystanders accumulating our organs. They may be playing an active role in damaging our organs. But what's most concerning is the brain. In both animal studies and also preliminary human studies, microplastics have been found to cross the blood-brain barrier. This is a highly selective membrane designed to protect the brain from harmful substances like microplastics. Once microplastics are inside, they can activate microglial cells. These are the brain's resident immune cells. Activated microglia can trigger neuroinflammatory responses, which over time may contribute to neurodegenerative diseases like Alzheimer's disease, like Parkinson's disease. In fact, a study using mice exposed the mice to microplastics, and it found that increased levels of pro-inflammatory cytokines were found in the brain, along with behavioral changes that were indicative of neurological impairment. While more research is needed to fully understand the implications for humans, I do think these findings are a significant cause for concern. And the reproductive system isn't spared either. A study discovered microplastics in human placentas collected after birth. The microplastic particles were found on both the maternal and fetal sides of the placenta, as well as within the amniotic membranes. So this suggests that microplastics can cross the placental barrier, potentially exposing the developing fetus to these particles during critical periods of growth. And in males, the situation is equally troubling. Human studies have detected microplastics in testicular tissue, in sperm, and even in the blood-testes barrier. This is a protective layer that shields the developing sperm cells from harmful substances. In animal studies, exposure to microplastics led to decreased sperm count, reduced motility, and alterations in sperm morphology. These changes raise serious questions about fertility and reproductive health in humans. One of the most significant and efficient transport systems for microplastics to reach our organs, like the brain, like the sperm, is our bloodstream. So one study published in 2022 was the first to detect microplastics in human blood samples. Researchers found that 80% of the participants had measurable levels of microplastics in their blood, with an average concentration of about 1.6 micrograms per milliliter. This finding confirms that once the microplastics enter our bodies, whether through inhalation or ingestion or even dermal contact, they can circulate in our bloodstream and then deposit in various tissues and organs. What I'm getting at here is that every time we drink from a plastic bottle or drink tap water contaminated with microplastics or eat food packaged in plastic or breathe air contaminated with microplastic fibers from synthetic clothing or tire wear, we are potentially introducing these particles into our bloodstream. The blood then acts as a highway delivering microplastics to organs where they not only take up residence, but they accumulate over time. And this is the concern: bioaccumulation. Microplastics don't degrade easily within the body. A study involving cardiac surgery patients found that the number of microplastics in their blood increased after surgery compared to before surgery. This suggests that microplastics persist in the body and are not readily eliminated, leading to bioaccumulation. This could have potential long-term health implications. But it's not just the plastics themselves that we need to worry about, right? It's also the chemicals they carry. Many microplastics act as vectors for endocrine disrupting chemicals like BPA, BPS, phthalates, and the PFAS. These are substances that can leach out and accumulate alongside microplastics in the body. We're going to discuss some of these health consequences in just a minute, but I want to drive home how important it is to understand this concept of bioaccumulation of microplastics. So far, it does not seem like microplastics have a way out once they make their way into our organs. This is key to understanding and grasping the health risk associated with them. Now let's discuss how microplastics and their associated chemicals like BPA, BPS, phthalates are impacting our endocrine system. This is not just a minor concern. It's a significant area of research because endocrine disruption means that these substances are interfering with hormone signaling in our bodies. And hormones, as many of you know, regulate everything from metabolism to reproduction to brain function. So let's start with BPA and BPS, which are classified as endocrine disrupting chemicals because they can mimic the body's natural hormones. Specifically, they act as xenoestrogens. These are foreign compounds that imitate estrogen by binding to estrogen receptors. When BPA or BPS binds to these receptors, they can either activate or block normal estrogen activity. This miscommunication leads to abnormal hormone signaling affecting reproductive health, brain development, and so much more. For instance, one study found that adults and adolescents with higher urinary BPA levels had lower testosterone levels and altered estrogen metabolism. This suggests BPA isn't just mimicking estrogen, but it's also disrupting normal hormonal pathways, throwing off this delicate balance of our endocrine system. Phthalates are another group of endocrine disruptors, and a certain metabolite of phthalates called DEHP in particular interferes with the HPG axis. This is essentially the command center for hormone production and regulation. By disrupting this axis, phthalates can then lead to reduced levels of critical hormones like testosterone and estradiol. And this doesn't just impact reproductive health, it has downstream effects: muscle mass, bone density, even mood. On the thyroid front, BPA and phthalates can interfere with thyroid hormone receptors. This disrupts the normal feedback mechanisms that regulate T3 and T4 thyroid hormone levels. These hormones are vital for metabolism, for energy levels, and cognitive function. Disruption here can lead to symptoms like fatigue, weight gain, cognitive impairments. Human observational studies have provided some evidence of these effects. So data from the National Health and Nutrition Examination Surveys, this is NHANES data, has repeatedly shown that higher urinary levels of BPA correlate with disruptions in sex hormone levels and thyroid function. In one study, pregnant women with higher BPA levels, they had children with altered hormone levels, particularly affecting thyroid function. Since thyroid hormones are critical for brain development, both in utero and throughout life, this finding does raise significant concerns. Now, conducting long-term randomized controlled trials in humans to assess the impact of these chemicals is ethically problematic. We can't knowingly expose people to potentially harmful substances. However, some short-term intervention studies have been insightful. For example, one study had participants consume canned soup daily for 5 days, which led to a 1,200 increase in urinary BPA levels compared to those who consumed fresh soup. This acute exposure of BPA led to measurable changes in their hormone levels, including decreased testosterone and altered thyroid function. When we turn to animal studies, the data becomes more supportive. Chronic exposure to BPA and phthalates in mice has shown not to just disrupt hormones, but also leads to physical changes. Male rodents exposed to BPA exhibited reduced sperm count, impaired sperm quality, and alterations in testosterone synthesis. And female rodents showed disrupted ovarian function, earlier onset of puberty, and irregular estrous cycles. A particularly interesting study involved exposing pregnant mice to BPA. The offspring of these mice showed behavioral changes such as increased anxiety and altered social interactions, suggesting that BPA exposure can have transgenerational effects impacting brain development and behavior. In terms of thyroid function, animal studies demonstrated that microplastics like polystyrene and chemicals like BPA disrupt thyroid hormone signaling. This leads to reduced levels of TSH, T3, T4. These hormones are critical for regulating metabolism. What was the result? Well, animals exhibited signs of hypothyroidism, including weight gain and lethargy. So what does this mean for us? The cumulative evidence suggests that even low-dose chronic exposure to these endocrine disruptors could impact our hormonal health in meaningful ways. The endocrine system doesn't just operate in isolation. It's interconnected with virtually every system in our body. So disruptions here can contribute to a cascade of health issues, from infertility to metabolic disorders to cognitive impairments to increased cancer risk. I want to take a moment now to shift gears and talk about BPA and reproductive health, starting with how it affects pregnant women and their developing babies. A study published in 2022 looked at BPA exposure in pregnant women and found that those with higher levels of BPA in their urine were more likely to give birth to boys who had slower growth rates during their early years. So what's happening here? Well, BPA is an endocrine disruptor. It's messing around with our hormones. And during pregnancy, hormones are very important for keeping everything on track for fetal development. BPA, which mimics estrogen, can throw off that balance. And so the study actually did find that BPA exposure disrupts estrogen signaling in the placenta. This interference might explain why boys had delayed growth. I think it's pretty unsettling when you think about how something as ubiquitous as BPA is found in everything, all these plastic food containers, in our drinking water, everything, how it could have such a profound impact on early development. And it's not just BPA that's causing concern. Phthalates, another class of chemicals that are everywhere in plastic bottles, food packaging, personal care products, on and on and on. What's troubling is how consistently phthalates interfere with male reproductive development, and it's really getting worse as our exposure to plastics increases. Multiple studies have now shown that higher phthalate levels during pregnancy are linked to a significant shortening of the anogenital distance in male boys. This is a key marker for reproductive health. So shorter anogenital distance in boys has been linked to a higher risk of birth defects like hypospadias. This is where the urethra doesn't develop properly, and also undescended testicles. And these aren't just cosmetic issues. They can lead to serious complications later in life, including infertility, hormonal imbalances, and even increased risk of testicular cancer. And it's not just high levels. Phthalate exposure, even at low concentrations, can disrupt the development of male reproductive organs. So what's the reason? Phthalates act as anti-androgens, meaning they block the action of testosterone, which is critical for male development. Studies have shown that phthalates disrupt hormonal signals during these crucial windows of fetal development, essentially hijacking the very process that shapes the male reproductive health. So the result is there's long-term impacts that can persist into adulthood. Fast forward and you see similar issues in men exposed to higher levels of phthalates. Research has shown that men with elevated phthalate levels have lower sperm quality and reduced testosterone levels, directly impacting fertility and overall hormone balance. And it's not just boys and men who are affected. In women, exposure to higher phthalate levels is associated with irregular menstrual cycles and a higher risk of endometriosis, which is a painful condition that can lead to fertility issues. The mechanism here is similar. Phthalates disrupt estrogen pathways, which are crucial for regulating the menstrual cycle and maintaining reproductive health. We're talking about chemicals that have made their way into our bodies through the products we use every day, through the water we drink every day, through the air we breathe every day. And phthalates don't need to be at high concentrations to wreak havoc. They're quietly causing this insidious damage to our hormonal systems that's building up over days and days and years and years and decades, and they're affecting everything from development, including neurodevelopment. And I want to talk about this now. So there's a potential link between BPA and autism spectrum disorder. There are multiple human observational studies that suggest a connection between maternal BPA levels and an increased risk of neurodevelopmental disorders, including autism spectrum disorder. For example, one study from Harvard School of Public Health found that higher BPA levels in pregnant women were associated with behavioral problems in their children, particularly boys. So these included issues like anxiety, aggression, impaired social functioning. These are traits that overlap with autism spectrum disorder symptoms. Another large cohort study followed pregnant women and their children over several years and found that higher maternal BPA exposure during pregnancy was associated with poor neurodevelopmental outcomes in children, including several behavioral problems. And again, these effects were more pronounced in boys. While the study didn't specifically diagnose autism, the behavioral impacts they observed align again with traits that are seen in autism spectrum disorder. There's also a meta-analysis that reviewed several studies on maternal BPA exposure and neurodevelopment. And although it didn't conclusively prove a direct link to autism, it did find consistent evidence that prenatal BPA exposure increased the risk of behavioral issues like hyperactivity and inattention, which are common in children with autism spectrum disorder and also other neurodevelopmental disorders. And when you pair that with the animal data, it becomes harder to ignore this potential connection. Animal studies have consistently shown that BPA exposure during pregnancy causes offspring to have deficits in social behaviors, increased anxiety, and altered brain structure in key areas like the prefrontal cortex and hippocampus, the same brain areas that's affected in humans with autism. And it's not just about BPA exposure during pregnancy. There's actually another layer to this. So one study found that children with autism spectrum disorder actually struggle to metabolize BPA. So their bodies aren't detoxifying the chemical as efficiently, so it builds up, especially in its active form, free BPA, which means it's circulating in their systems longer and potentially affecting brain development throughout childhood and adolescence. This is important because estrogen receptors in the brain play a key role in things like cognition, memory, social behavior, areas that are often impacted in autism. Some research actually suspect that this impaired metabolism of BPA in kids with autism spectrum disorder could be disrupting those key neural pathways, which could explain some of the cognitive and behavioral challenges that are seen in autism. It's almost like this 1-2 punch. First, you've got maternal exposure during pregnancy, which affects the structure and development of the brain. Then, if that child is less able to metabolize BPA efficiently, it sets up this prolonged exposure to a chemical that's known to interfere with brain development. So animal studies consistently show that early life exposure to BPA disrupts neuronal circuits responsible for learning, attention, behavior, and this could explain some of the cognitive and social deficits seen in children with autism spectrum disorder. But the effects of BPA on the developing brain don't end with autism. There's also evidence that prenatal exposure to BPA is linked to a higher risk of behavioral problems like anxiety, attention disorders, and even ADHD. So a study published in 2017 found that kids who were exposed to higher levels of BPA during pregnancy were more likely to develop ADHD along with anxiety and depression later in childhood. So how does BPA do all this damage? Well, it seems like it interferes with the key neurotransmitter systems, specifically dopamine and serotonin, that affect brain function. So these chemicals are crucial for regulating mood, attention, cognitive function, and during development, serotonin actually plays a key role in shaping the structure and function of the brain. It's actually called a brain morphogen during development, so it's shaping the growth and differentiation of neurons during early life. It acts as a growth factor during embryonic development, influencing the development of key brain regions like the cerebellum by promoting dendritic growth and synapse formation and stabilization. These are critical processes for proper neural circuit formation and coordination between brain regions. Disruption of the serotonin system during this very critical period could absolutely affect brain development. In fact, vitamin D deficiency during pregnancy may also disrupt serotonin production, which could affect autism risk. I actually published 2 studies on this very topic a few years ago. So the fact that BPA is linked to autism and it disrupts the serotonin system, and vitamin D deficiency also is linked to autism during pregnancy and also disrupts the serotonin system, to me, strengthens the connection, because when you start to see different environmental factors that are all sort of aligning and converging on a similar mechanism, it's really hard to ignore. So on top of that, BPA also induces oxidative stress in the brain. So this means it's generating harmful free radicals that damage brain cells. It impairs their ability to communicate and to adapt. This is what we call synaptic plasticity. That oxidative stress can also trigger inflammation, which just sort of amplifies the damage, especially in developing neurons. Now, I want to get on to something that we touched on earlier in the podcast that also is pretty concerning, and it's the idea that microplastics could actually be making their way into the adult brain. So when we think about how the body protects the brain, we usually think of the blood-brain barrier. This is a highly selective shield that's supposed to keep harmful substances out of the brain. But there's emerging evidence suggesting that microplastics, especially the smaller nanoplastics, so these are less than 1 micrometer, can actually cross the blood-brain barrier. And once they're in, they could cause some real damage. For example, one study found that polystyrene microplastics were accumulating in critical brain regions like the hippocampus and the prefrontal cortex. These are areas responsible for memory, for learning, for emotional regulation. When these microplastics settle into brain tissue, they can trigger an inflammatory response. They spike levels of pro-inflammatory cytokines like TNF-alpha, IL-6. These are markers that are associated with chronic brain inflammation. And we know chronic brain inflammation is linked to neurodegenerative diseases like Alzheimer's disease, like Parkinson's disease, and even just normal cognitive decline. If you want to learn more on how neuroinflammation plays a major role in the development of neurodegenerative disease, please check out my previous episode number 79 with Dr. Axel Montaigne on the blood-brain barrier and Alzheimer's disease. And it's not just animal studies that's showing this connection. There's emerging human data showing accumulation of microplastics in brain samples taken from human autopsies. In one study, research examined tissues from livers, kidneys, and brains of autopsied individuals. While all organs contained microplastics, that's concerning, the brain samples alone were particularly concerning because on average, of the 91 brain samples studied, They contain 10 to 20 times more plastic in the brains than other organs. And these findings are even more disturbing when you consider their implications for neurodegenerative diseases. Among the brain samples studied, 12 were from individuals who had died with dementia, including Alzheimer's disease. These samples contained up to 10 times more plastic by weight compared to those people who had plastics in their brains without dementia. While this doesn't yet prove causation, I think the correlation is enough to raise serious concerns about the role of microplastics in cognitive decline and diseases like Alzheimer's disease. What's also striking is the increase in microplastic concentrations over time. So human brain samples from 2024 had about 50% more plastic than similar samples dating back to 2016. This trend mirrors the rising level of microplastics found in the environment, suggesting that as our environmental plastic pollution increases, so does the plastic accumulation in human tissues like the brain. So the question becomes, what does long-term, low-dose exposure look like for humans, especially in urban environments where microplastic air pollution is high? And what about kids? So we already discussed this somewhat. During early development, the blood-brain barrier is even more permeable, which means that pregnant women and young children could be at a greater risk for neurodevelopmental issues like autism or ADHD if exposed to microplastics. And observational evidence seems to suggest that this is the case for chemicals associated with them as well, like BPA. So the implications are that we could be looking at higher risk of neurodegenerative diseases, cognitive impairments, and even neurodevelopmental issues if exposure starts early in life. This is something we absolutely need more research on, but the early signs are not good. Let's shift gears and talk about fertility. BPA is something I really want to emphasize here because its impact on fertility is pretty alarming. There's a lot of research out there that shows just how much BPA exposure can interfere with women's reproductive health. Let's start with egg quality. So there's a study that looked at women going through IVF, and what was found was kind of shocking. Women with higher levels of BPA in their urine had half as many viable eggs as women with lower BPA levels. And that's huge. Imagine your chances of a successful pregnancy being cut in half just because of your exposure to a chemical found in everyday plastics. But it doesn't stop there. BPA also messes with ovarian function by disrupting the hormonal balance that's crucial for regular ovulation. It interferes with estrogen and progesterone, which are basically the key players in regulating our menstrual cycle. This means even if you're not trying to conceive right now, BPA could be impacting your ability to ovulate consistently and prepare your body for pregnancy when you're ready. And then there's implantation. This is the process where the fertilized egg attaches to the uterine wall. Even if everything else is in order, BPA can affect the uterine lining and make it harder for a fertilized egg to implant. One study showed that women with higher BPA levels had lower implantation success during IVF, which makes it clear that this isn't just a hypothetical concern. BPA is affecting the body's natural ability to support early pregnancy. And BPA may also play a role in puberty as well because of its ability to mimic estrogen. So studies have shown that exposure to BPA at critical stages of development, such as early fetal life, infancy, or even early childhood, is linked to early onset of puberty in girls. A study published in 2016 found that girls with higher prenatal BPA exposure had earlier breast development and menarche, which is the first menstrual period, which can have long-term health consequences, including increased risk for breast cancer later in life, earlier menopause later in life, etc. And for men, BPA exposure is also a concern when it comes to fertility. Now, we've known for a while, again, BPA can act like estrogen in the body, which can disrupt hormone balance, but its effects on sperm are really alarming. So a study published in 2020 found that men with higher levels of BPA in their systems had lower testosterone levels, and unsurprisingly, their sperm quality was also significantly reduced. So think about this. They had lower sperm count, reduced motility, and even structural abnormalities that were found in their sperm. And these are men who otherwise would seem healthy. Testosterone, as we know, is crucial not just for reproductive health, but for overall health. And when BPA gets into the body, it can start to mess around with the endocrine system in ways that affect all these areas of male fertility. What was also interesting about this study is that researchers found that this decline in sperm quality was found at relatively moderate levels of BPA exposure, which really highlights, again, how pervasive this issue is. BPA is everywhere. Plastics, food containers, canned goods, receipts. So this exposure adds up quickly, and this is where we start to see these systemic effects that have very real consequences on health and fertility. But honestly, BPA is just the tip of the iceberg when it comes to what's going on here. Microplastics are also playing a pretty significant role, and this is where it can get even more concerning. There was a study that looked at semen samples from 40 healthy young men who should be in their prime reproductive years. And get this, every single sample had microplastics in it. On average, there were 2 particles per sample. And these weren't just harmless specks. We're talking about plastic particles ranging in size from 0.7 micrometers to 7 micrometers. So they're small, but they're definitely there. And the most common type that was found was polystyrene. This is stuff that's found in packaging. It's in containers. That made up around 31% of the total. But what's really troubling is that what is this doing to sperm? These microplastics were linked to abnormal sperm shape and impaired motility, meaning their sperm couldn't move as efficiently. And one of the worst culprits was PVC. This is the same plastic used in things like water pipes. This is where our tap water is coming from. So small particles from PVC can break down and leach into our water supply over time. So tap water is a huge source of microplastics. So here we are. Microplastics aren't just an environmental issue, they are a human health issue. We've got them inside our bodies, even affecting fertility, which is something that feels so fundamental. And it raises the question, if microplastics are doing this to healthy young men, what else are they doing to our overall health? It's something we really need to pay attention to. Okay, now let's discuss how microplastics and their associated chemicals like BPA, phthalates, could play a role in cardiovascular disease. Much of the focus has been on how these substances affect hormones and metabolism, but there is some growing evidence that they could have an impact on the heart and also on blood vessels. So BPA doesn't just mess with our hormones, it actually directly affects our heart's ability to function properly. One of the key mechanisms here is how BPA disrupts calcium signaling in heart cells. So calcium is essential for the electrical activity of the heart. It helps regulate things like heart rate, contractile function, and even how blood vessels dilate. Studies have shown that acute exposure to BPA can inhibit voltage-gated calcium channels, which impairs how cardiomyocytes, these are the cells in our heart, handle calcium. And this disruption can affect how the heart contracts, and it can trigger abnormal activities in the heart muscle. What's interesting is that these effects seem to hit men and women differently, likely due to BPA's interaction with estrogen, which is a hormone that plays a key role in regulating heart function in women. Another set of chemicals that we've been discussing, phthalates, can act as cardiodepressants, meaning they slow down the heart rate and they interfere with the way electrical signals move through the heart. This not only weakens our heart's ability to contract, but also slows blood flow down. It makes it harder for our hearts to do its job efficiently. And these effects can build up over time. They can contribute to chronic heart problems. In rodent studies, exposure to a metabolite of phthalate called DEHP has been shown to decrease coronary flow and reduce the heart's ability to contract properly. Phthalates slow down heart rate and the speed at which electrical signals travel across the heart muscle. So this means phthalates are directly suppressing cardiac function. Now let's talk about microplastics themselves. Microplastics have been found embedded in arterial plaques. A study published in the New England Journal of Medicine found that patients with microplastics lodged in their arterial walls were 4.5 times more likely to experience a major cardiovascular event like a heart attack or stroke within 3 years compared to patients that did not have microplastics in their arterial walls. Microplastics were detected in 58.4% of patients undergoing surgery for heart disease. This suggests that chronic exposure to these particles could be playing a significant role in cardiovascular events. What's happening here is likely twofold. First, microplastics can promote chronic inflammation, which is a key driver of atherosclerosis, or the buildup of plaque in the arteries. Second, these particles carry harmful chemicals like BPA and phthalates directly into the arterial walls. So these chemicals may further contribute to the formation of plaque and may also increase the risk of heart attack or stroke. Another concern is the link between BPA exposure and hypertension. In a randomized controlled trial, researchers found that participants who drank from BPA-lined cans experienced a significant spike in blood pressure, about 4.5 millimeters of mercury increase in systolic blood pressure within hours. So the lead researcher of this study warned that repeated exposure to BPA could be contributing to chronic hypertension. This is a condition that's already affecting nearly a third of the global population. High blood pressure is a major risk factor for heart disease and stroke. So this connection adds another layer of concern regarding everyday BPA exposure. But what's even more concerning is how chronic exposure to BPA may drive cardiovascular mortality over time. A study that analyzed NHANES data from over 9,000 participants followed people for about 9 years and found that those people with the highest urinary BPA levels were 1.76 times more likely to die from cardiovascular disease. Interestingly, these effects were far more pronounced in women. So women in the highest exposure group had about a 2.8 times higher risk of a cardiovascular death compared to women in the lowest group for BPA levels. For men, there was still an elevated risk, but it was not as extreme. So this isn't just about BPA raising our blood pressure in the short term. We're talking about a serious long-term risk of dying from heart disease. And it appears that women are especially vulnerable. And again, it's not just BPA, but also the microplastics themselves accumulating in the arterial walls and possibly increasing heart attack risk. This really highlights the critical importance of reducing microplastic exposure, of reducing our exposure to BPA in everyday life. Whether that means we're making more informed choices about choosing glass over plastic or avoiding canned foods, which are lined with BPA, or even just filtering our tap water. We'll get to more on that in just a minute. But first, I want to shift gears and talk a little bit about what we know about microplastics and their associated chemicals when it comes to cancer risk. So this is a topic that's gaining more attention as new data emerges. As we've been discussing, one of the key concerns with microplastics is not just the particles themselves, but the chemicals they carry, including phthalates and BPA, both which are endocrine disruptors. Because these substances interfere with our hormonal systems, there could be an effect on cancer risk. Let's start with phthalates. So a study published in 2022 looked at about 1.3 million children in Denmark over a 20-year period. The study found that childhood exposure to phthalates was associated with a 20% higher overall risk of childhood cancer. But it didn't stop there. The study highlighted specific cancers, showing that children exposed to phthalates had nearly a 3-fold higher rate of osteosarcoma. This is a rare bone cancer. And they had a 2-fold higher rate of lymphoma. So this is a blood cancer. What makes this study particularly robust is the data set. So Denmark has a universal healthcare system that provides very detailed records, allowing researchers to track medication-associated phthalate exposure with more precision. So the findings are very significant because the phthalate exposure here wasn't just environmental or dietary. It was actually tracked through medication fills containing phthalates. So it represented a higher exposure than normal, typical environmental levels. But still, I think these results should make us question what background exposure from our everyday environment could be doing, especially over time. The connection between phthalates and breast cancer is also emerging. A meta-analysis pulled data from 9 case-controlled studies involving over 7,800 participants across multiple countries, and it found that specific phthalate metabolites were positively associated with breast cancer risk. These are the kind of details that matter. We're not just talking about vague associations here. These are metabolites from specific phthalates showing a clear connection to cancer risk. So the question becomes, how much cumulative exposure are we really getting? And more importantly, how does this cumulative exposure build up over years or even decades to affect our cancer risk? Because cancer really does take decades to develop. There's also a growing body of research linking BPA exposure to breast cancer. So BPA acts by mimicking estrogen, which plays a central role in the development of breast cancer. Studies have shown that even low-dose exposure to BPA can promote the growth of estrogen-sensitive breast cancer cells in laboratory settings. And we know from population-level studies that chronic low-dose exposure, the kind we're getting from everyday contact with BPA in plastics or canned food linings, even receipts, can accumulate. And so the question is it possible this cumulative exposure over decades can increase breast cancer risk, particularly in women that may already have a higher risk for genetic or other lifestyle factors? One of the reasons microplastics are so concerning is they act as a carrier for these chemicals. The plastics themselves can accumulate harmful chemicals like BPA, phthalates, and even heavy metals, transporting them into our bodies, again, via the air we breathe, the water we drink, and the food we eat. And once they're in the body, microplastics can be bioaccumulative, meaning they're building up in our tissues over time. Microplastics have also been found in human tumor samples. In a study that was conducted on patients with lung cancer, researchers found microplastic particles in tumor tissue, suggesting that these foreign particles might play a role in cancer development or progression. The presence of microplastics in tumor tissue is alarming because of their ability to cause chronic inflammation and potentially carry these harmful chemicals like BPA and phthalates directly into the tumor microenvironment. While it's not yet clear whether these particles are directly playing a role in causing cancer, the fact that they can infiltrate tumor tissue highlights their potential to influence tumor biology, possibly by exacerbating inflammation or even interfering with immune responses. There's obviously a lot to be learned here, but I do think the preliminary data is cause for concern and more research needs to be done in this area. Now I want to talk about practical strategies for reducing our exposure to microplastics and their associated chemicals. And let's start with water. The most straightforward action is to minimize drinking water from plastic bottles and cans. Plastic bottles can leach microplastic and chemicals like BPA and BPS into water, and cans are often lined with plastic coatings containing these substances. But even if you're opting for water in glass bottles, there's another layer to consider, and that is the quality of the water itself, especially when it comes to carbonated water. This is where the forever chemicals enter. These are the per- and polyfluoroalkyl substances, PFAS. As we discussed earlier, they are referred to forever chemicals. They are particularly troubling because they have half-lives that are several years long, meaning they persist in the body and accumulate over time. So PFAS have been linked to a range of health issues, including hormonal disruptions, immune system effects, even certain cancers. In 2020, Consumer Reports conducted third-party testing, and they published data on several popular brands of sparkling water to measure PFAS levels. The findings were eye-opening. Topo Chico topped the list with PFAS levels at 9.76 parts per trillion. To put that into perspective, Perrier registered at about 1.1 part per trillion, and San Pellegrino, which was even lower, at 0.31 part per trillion. Both Perrier and San Pellegrino are often available in glass bottles, which is an added advantage for reducing plastic exposure. And I do think it's encouraging that multiple brands did achieve PFAS levels below 1 part per trillion, which demonstrates that it's entirely feasible to provide safer options. But this raises a critical question. Why do some brands like Topo Chico have such high levels of PFAS? In 2023, Coca-Cola, which is the parent company of Topo Chico, claimed they had reduced their PFAS levels by about half. However, without any actual transparent empirical data to confirm this, and even if it was accurate, that would still leave their PFAS levels at around 4.88 parts per trillion, which is significantly higher than many other brands that have less than 1 part per trillion of PFAS levels in their sparkling waters. So I think this situation does underscore a very important point, which is that we can't always rely on bottled or canned water, even from brands we trust, to be free of contaminants. So how do we ensure that the water we're consuming is safe? I think the answer lies in taking control of our water quality at home. And one of the most effective ways to do this is by installing a reverse osmosis filtration system. So reverse osmosis filters can remove up to 99.9% of microplastic particles from water. It's really one of the best solutions for obtaining clean drinking water. Beyond microplastics, these systems also filter out a wide range of contaminants, everything from heavy metals to bacteria, and even chemicals like BPA and the PFAS forever chemicals. Now, it is important to note that reverse osmosis filters don't just remove the bad. They also strip away beneficial minerals and trace elements. So this is everything from calcium, magnesium, potassium, sodium, phosphorus, a variety of others, zinc, iron, copper, and selenium, iodine, manganese, and on and on. There's more. These minerals are essential for various functions in the body, obviously everything from bone health to nerve signaling, but there are practical solutions to this issue. Many reverse osmosis systems now come with a remineralization filter option that can add back these essential minerals and trace elements back to the water after they're purified. Alternatively, there's high quality mineral drops that can be added back to the filtered water, or people can just supplement with mineral supplements. I do think that an added benefit of having a reverse osmosis home filtration system is its versatility, because not only can you use this water for drinking, but you can use the purified water to wash fruits and vegetables and a variety of produce, which can be contaminated with microplastics on their surface from soil, from contaminated water, from air exposure where these particles settle on the surface of the produce. So washing produce with filtered water can help remove some of these microplastic particles that cling to surfaces, particularly waxy surfaces on certain produce. When it comes to food, opting for fresh over packaged food is another obvious, impactful choice. So packaged foods often come wrapped in plastic. Those can shed microplastic and leach chemicals like BPA into our food. So by choosing fresh produce, fresh meats, bulk items, we can minimize the exposure, which is good for our own health, but also promotes environmental health as well. Similarly, we should consider reducing our consumption of canned foods and canned beverages. So many aluminum cans are lined with plastic coatings. These coatings contain BPA, or they have alternatives like BPS, which carry similar health risks. So whenever possible, it's better to select products that are packaged in glass versus cans. We can also reevaluate our food storage habits, so opting for glass or stainless steel or ceramic containers instead of plastic ones. Avoid heating food in plastic containers. Remember, heat can accelerate the leaching of chemicals like BPA into our food, into our beverages. It also accelerates the oxidation process, which then causes more microplastics to be shed from the larger plastic itself. And remember, microwave safe simply means the plastic won't melt. It doesn't guarantee that it's free from chemical leaching. Also try to avoid cooking with nonstick pans, which are coated with some of these chemicals like the forever chemicals. So try to opt for options like titanium, ceramic, cast iron. These are all other options that we should be using for cooking our foods, because again, heat is causing these chemicals to be leached into our foods at an even higher and accelerated rate. Which brings me to another crucial point, and I want to talk about this myth of BPA-free products. There's a lot of these BPA-free products which sound like they're safer alternatives, but they're not. Manufacturers frequently replace BPA with chemicals like BPS, which also can disrupt hormonal activity in much the same way. And studies have shown that BPS may not be a safer option than BPA, and potentially causing adverse health effects on fetal development, brain health, cardiovascular function. Some BPA-free plastics even contain phthalates or other harmful plasticizers. So the term BPA-free merely means the product lacks BPA and not that it's free from all other toxic chemicals. I also want to again highlight and bring your attention to a common daily exposure to microplastics and their associated chemicals, and that is disposable paper, coffee, and teacups. These convenient paper cups are typically lined with plastic to prevent leaks. Here's the issue. When you pour that hot beverage into them, the heat causes the plastic lining to break down. You're getting microplastics into the beverage. You're leaching chemicals like BPA into your beverage at a much higher level. I already talked about a study where heat can cause the leaching of BPA up to 55 times higher compared to cold liquids. So a simple solution really is just to bring your own reusable to-go mug to a coffee shop. If you're enjoying a drink at the cafe, ask for a ceramic cup. If you're on the go, just bring your own mug. And most baristas are actually happy to fill your own travel mug. Some shops actually even offer a discount for doing so. When it comes to oral consumption of microplastics and their associated chemicals, I want to address another hidden source of microplastics, and that is salt. It may or may not surprise you, but salt can significantly contribute to our microplastic intake. Estimates suggest that consuming salt can add around 7,000 microplastic particles to our diet each year. And that's a conservative figure. So sea salt generally has the highest levels of microplastic contamination due to the ocean pollution. One study found that sea salts contained anywhere from 550 to 681 microplastic particles per kilogram, making them some of the most contaminated sources of salt. Lake salts come next, followed by rock salts, which have the least amount of microplastic contamination. So rock salts include commonly used varieties like Morton's iodized salt or pink Himalayan salt. So these salts do still contain some microplastics, but the levels are significantly lower than what's found in sea salts. So whenever possible, opting for rock or mined salts can reduce microplastic intake. Okay, now let's turn our attention to the air we breathe. This is another significant yet often overlooked source of microplastic exposure. Reducing the amount of microplastics we inhale is crucial, and fortunately, there are a few practical steps that we can take to minimize this risk. First and foremost, let's consider our indoor environments. This is where we spend the majority of our time. One effective strategy is to use a HEPA filter. This is a high-efficiency particulate air filter. Using these in our homes can be highly efficient at trapping airborne microplastic particles. They can capture particles as small as 0.3 microns, making them pretty suitable for removing the vast majority of microplastics found in indoor air, many of which range from 10 to 100 microns in size. A significant portion of airborne microplastics originates from synthetic textiles, from carpets, and other household materials. Every time we walk across a synthetic carpet or we sit on a polyester couch, tiny plastic fibers can become airborne. By using a HEPA filter, especially in areas where synthetic materials are prevalent, we can significantly reduce the number of microplastics floating around in our indoor air. Moreover, many modern vacuum cleaners actually now come equipped with a HEPA filter. So this feature allows them to trap microplastics effectively when they're cleaning floors or carpets, and it prevents these particles from being redistributed back into the air. So regular vacuuming with HEPA filters can also make a substantial difference in indoor air quality as well. Now let's address the source of many of these airborne microplastics, our clothing. Synthetic fibers like polyester, nylon, and acrylic are ubiquitous in today's fashion. These materials offer benefits like durability and affordability, but they also shed microplastics into the environment, both into the air and also through washing. One impactful change is to opt for clothing made from 100% natural fibers. So this is cotton, bamboo, linen, hemp, wool, or silk. These materials do not shed microplastics. But it is important to note that even blends containing synthetic fibers can still release microplastics. So aiming for pure natural fibers is really key here. I understand this might be challenging, especially for people that have specific fashion preferences or budget considerations, but even gradual shifts in our wardrobe can make a significant difference over time. For those of us not ready to 100% part with our synthetic garments, there are ways we can also still mitigate the impact. Installing a microfiber filter on our washing machine is an effective method. So washing synthetic clothes is a major source of microplastic pollution in the ocean, in our waters. And so installing a microplastic filter can actually trap microplastic fibers released during washing of our laundry and prevent them from entering our waterways. There's also brands like Guppy Friend that offer these laundry bags that are designed to catch microfibers during washing. So these bags really offer a straightforward and cost-effective solution for people that are not really ready to install a microfiber filter on their washing machine just yet. I also want to highlight another pathway through which microplastics and their associated chemicals like BPA can enter our bodies, and that is through the skin. So dermal absorption isn't as significant as ingesting contaminated food or water or inhaling polluted air, but it is still a route worth paying attention to, especially because it involves everyday items we might not suspect. So consider thermal paper receipts. These are things that we're getting from the supermarkets, gas stations, ATMs. These receipts often contain BPA, which is used as a color developer in the thermal printing process. So when we handle receipts, BPA can transfer into our skin and potentially enter our bloodstream. Now, here's where it gets more interesting and concerning is that the use of lotions or sunscreens or hand sanitizers can dramatically increase the absorption of BPA through the skin. These products can enhance our skin's permeability, which allows BPA to pass through the skin more so than it normally would. In fact, studies have shown that using hand sanitizer before handling receipts can significantly boost BPA absorption into our bloodstream. So what can we do about this? When possible, opt to decline paper receipts or request a digital version, have it sent to your email or phone. Many retailers offer this option and it reduces BPA exposure to ourselves, but it also reduces paper waste, so it's a win-win. If your job requires you handling receipts frequently, such as if you're in a retail or food service, consider wearing nitrile gloves. So nitrile gloves are effective barriers against chemicals like BPA, unlike some latex glove, which may not offer the same level of protection. Okay, lastly, I want to cover some excretion methods. I want to talk about how our bodies handle the influx of microplastics and the chemicals associated with them, including BPA, BPS, phthalates, and the forever chemicals, the PFAS. So once these chemicals enter the body, whether it's through ingestion or inhalation or through skin contact, they are quickly absorbed and processed primarily by the liver. The liver is equipped with a variety of enzymes. Part of these enzymes are called phase 2 detoxification enzymes. These are enzymes that convert these chemicals into more water-soluble forms, making them easier for our body to excrete them, mostly through urine. For example, BPA is cleared relatively fast within about 6 hours under normal conditions. Phthalates take a bit longer, ranging between 12 to 24 hours, depending on the specific compound. While that might sound reassuring, the problem is we are exposed to these chemicals almost constantly, so our bodies are in a near continuous state of processing them. But this is where it gets even more complicated. So PFAS, again, these are forever chemicals, do not break down easily. So unlike BPA or phthalates, the PFAS have a half-life of 2 to 5 years, meaning they accumulate in our organs like the liver and the kidneys. And their persistence in the body makes them much harder to eliminate. They stick around and they build up over time. Then there's microplastics themselves. Microplastics do vary in size. Larger particles could pass through the gut and be excreted in feces, but the smaller nanoplastics, these are the really, really tiny particles, these are crossing biological barriers and they're entering the bloodstream. Once they get into circulation systemically, we don't really fully understand how or if they're ever excreted efficiently. What we do know is that they are accumulating in our organs, in our tissues, and this is a growing concern when we talk about long-term health implications. So how do we help our bodies clear out chemicals like BPA, BPS, and phthalates more efficiently? One promising strategy revolves around tapping into our body's natural detoxification systems. And we can do that through dietary and lifestyle interventions. One compound that really stands out here is sulforaphane. You've probably heard me talk about this before. It's a powerful molecule found in broccoli sprouts and other cruciferous vegetables. Sulforaphane activates a key pathway called NRF2. Think of NRF2 as the master regulator of detoxification. It controls the production of enzymes that helps our body clear out many, many toxins. It boosts the phase 2 detoxification enzymes. These are enzymes that bind to harmful chemicals and make them more water soluble so we can excrete them through our urine. Animal studies have shown that when rodents are exposed to BPA and given sulforaphane, their phase 2 detoxification enzymes go into overdrive and they experience less overall BPA-related toxicity. Now, while there's not a lot of direct evidence on sulforaphane's ability to clear BPA and phthalates specifically, I think the mechanism here is very solid, and we do have compelling human data in other areas. For instance, studies show that sulforaphane can increase the excretion of toxins like benzene and acrolein, which we get exposed through air pollution and food, by up to 60%. So in my view, incorporating sulforaphane-rich foods into our diet, like broccoli sprouts, which contain up to 100 times more sulforaphane than mature broccoli, or considering a high-quality supplement of stabilized sulforaphane or its precursor, glucoraphanin, could be a viable strategy for helping detoxify BPA, BPS, and phthalates. And by doing so, we do boost our body's natural detoxification pathways that has been shown in human studies that could help us more effectively eliminate some of these microplastic associated chemicals. Another avenue worth exploring is the role of dietary fiber in helping our bodies eliminate chemicals associated with plastics and perhaps even some microplastics themselves. Consuming fiber-rich foods can bind to lipophilic chemicals like BPA and phthalates in the GI tract and reduce their absorption into the bloodstream, promoting their excretion via feces. So feces is another way our bodies detoxify BPA, phthalates, and even microplastics. Some animal studies support this mechanism, indicating that higher fiber intake leads to increased fecal excretion of these compounds. But what about microplastics themselves? While research is still emerging here, I think there's a reason to believe that dietary fiber could aid in the excretion of some larger microplastics. So since microplastics can be trapped within the gut lumen, a fiber-rich diet could potentially help encapsulate these particles and facilitate their removal through regular bowel movements. Essentially, fiber might help sweep the gut clean and reduce the residence time of microplastics, therefore limiting their chances of causing harm and getting into the bloodstream. This means incorporating foods that are high in fiber, like legumes, fruits, vegetables, whole grains, could serve a dual purpose. Not only do they provide essential nutrients and micronutrients and phytochemicals and fermentable fiber that supports overall health and gut health, but they also could enhance the elimination of both harmful chemicals and microplastic particles. Let's talk about another powerful tool for eliminating some of these microplastic associated chemicals: physical activity and practices that induce sweating. So exercise, things like sauna, hot tubs, even hot yoga. Sweat, it's not just about cooling down the body, it's also a way to eliminate harmful chemicals and compounds from the body. So sweat does can trace amounts of BPA and phthalate metabolites. Now, while most of these chemicals are excreted through urine, studies have shown that sweat can help too. One study published in the Journal of Environmental and Public Health found measurable levels of phthalates in sweat of participants. I think this tells us that regular sweating, whether through exercise or sauna or hot yoga, can be a viable route for excreting some of these harmful substances. So while the amounts of BPA and BPS and phthalates that are excreted in sweat are smaller compared to urine, I think consistent sweating could really still play a meaningful role in lightening the toxic burden load on our body. And lastly, I do want to make one last mention that these excretion strategies that we've been discussing are less effective for the forever chemicals, the PFAS, because of their resistance to metabolic breakdown, because their half-life in the body is 2 to 5 years. So really the best way to avoid PFAS is to avoid the exposure in the first place, and reducing our exposure to plastics does remain the most effective way to reducing our burden of PFAS chemicals. So this means avoiding plastic chemicals, avoiding mineral waters with high concentrations of PFAS, and really just trying hard to reduce our use of plastics. So this wraps up our deep dive into the pervasive issue of microplastics and their associated chemicals. So I want to leave you with this. Microplastics and their associated chemicals are not just an environmental concern. They're posing a significant human health challenge that's impacting us at multiple biological levels. These microplastic particles infiltrate our bodies. They're accumulating in vital organs like our brain. They're disrupting hormonal balance. They're impairing fertility. They're posing substantial risk to our neurological and cardiovascular systems. But there is a constructive path forward by educating ourselves and making deliberate, informed choices, such as implementing effective water filtration systems to reduce our microplastic intake, opting for fresh foods over packaged ones, choosing clothing made from natural fibers instead of synthetic ones when possible, supporting our body's natural detoxification processes through proper nutrition and things like cruciferous vegetables and broccoli sprouts, sweating, exercising, using the sauna. These are all ways that we can actively reduce our microplastic exposure and their associated chemicals. I also hope that by raising awareness and advocating for systemic changes, we can contribute to a global effort for policy changes aimed at reducing plastic pollution. Remember, our individual actions, when they're multiplied across communities, they can lead to a significant impact. And I do think that if we work together, we can have the capacity to not only protect our own health, but that of future generations as well. Thank you for joining me in this important conversation today. If you're interested in learning more, make sure to check out my microplastics topic article. You can find that on my website at foundmyfitness.com. Go to the topics tab in the toolbar and scroll down to M, where you can find the microplastics article with references. You should also consider becoming a Found My Fitness member, where you get to ask me questions in a live and recorded Q&A every month. I very often answer questions related to the topics discussed in today's episode, things like microplastics and plastic exposure and BPA and reverse osmosis filters and which ones are the best and HEPA filters and all those kinds of questions. You can find that information on my website at foundmyfitness.com. Thank you so much, and I'll talk to you guys soon.